Hi all, I'm Charulatha and I'm going to explain my project presentation. C++ is an object-oriented programming language which has concepts like conceptors, descriptors, classes, objects, etc. We also learned how embedded C differs from C programming. Embedded C is a set of language extension for C programming language. Embedded C was most of the syntax and semantics of standard C. We use embedded C++ for programming the Arduino UNO. Embedded system is a combination of hardware and software that will perform a certain task. It is like programming the physical objects. Some real-time aspects are hard real-time, which should meet in deadline, like life-critical application. Firm real-time, which is similar to hard real-time properties. Finally, soft real-time, which can have tolerance in meeting its deadline. We used Arduino UNO in this project. Arduino UNO is the development board for Mega 328P, which is a 8-bit microcontroller. The Arduino UNO has 6 analog pins, A0 to A5. There are some pulse with modulation supported pins among digital pins. The resolution of ADC is 10 bits. The maximum voltage is 5 volt. Project requirement. First, let's see our garden lights. Control system. Our aim is to control the garden lights based on the availability of lights. That is, during day the lights should off and when it turns darker the lights should turn on. To sense the daylight, we are going to use the LDR sensor which acts as an input and data from LDR is sent to Arduino which sends the required control system and controls garden light. Next, we are going to control the temperature system of our home. Temperature control system consists of heating resistor, temperature sensor, cooler which resembles the temperature control system at home. The process is to read temperature from the temperature sensor and display it on CLCD. We will control the temperature of the room using heater and a cooler. To cool the temperature, we use temperature cooling system. The temperature sensor is used as input to acquire the current temperature detail and temperature data in CLCD. Our process is to deduct change in the logic level. Cooler and heater is controlled by using Blink app. Next, we can see water tank inlet and outlet valve control. To read the volume of water in the tank through serial communication and display on CLCD. Control volume of tank by controlling inlet and outlet by sending command through serial communication. Next components we used in this project. We use 16 by 2 LCD display which denotes 16 columns and 2 rows. 16 columns represent number of characters and rows represent number of heights. We used PCF8574 input-output expander. We also use 8-bit independent colored LEDs as output. We use ETHW5500 which can support up to 8 sockets simultaneously. All listening pods below 2000 are increased by 2000 to avoid operational system services holes. Temperature control system consists of heating resistor, an LM35 temperature sensor, a cooler and infrared tachometer. Blink application. Step-by-step process for configuration. Create virtual pins, select data streams, create template, add weights and then data stream to widgets. Interfacing all this using Blink Cloud. Tools or software used. Arduino IDE, Null Emulator, PiximLab, Blink app. Moving on to project integration. Interfacing all peripherals with Arduino and programming it. Then configure Blink app. Control temperature using Blink and CLCD. Configure serial tank using UART serial communication. Finally, conclusion. We simulated IoT-based home automation solution with features like garden lights, temperature system, and serial tank. We use Blink IoT app, Arduino IDE, PiximLab to do this project. CLCD acts as dashboard. Button weights and gauge widgets to control and display certain tasks respectively. Thank you.